Hey everyone, I'm David Room, and we've got some fun stuff in store tonight. I'm working on a new ship for the game, a new design of a fighter ship, and I thought I would share it with you guys. So the background here is every September there's this event on Twitter called Spaceship Timber, and while I talk about this, I'm going to just make a tweet that I'm live here on Twitter. There's this event called Spaceship Timber where there's prompts for each day and for different types of spaceships people make and share their images. Past couple of years, I've done a couple of them. Usually, it's not something that I do multiple days of because I don't have a ton of time and I don't turn around my designs into finished products in a day. But I was having kind of a laid back weekend and I got some ideas for a design, so I thought I would try to do a new fighter design. I don't have maybe as many fighters as I would like for my game, so I thought I would try to make a new one, and I had some good ideas. So I started sketching one out on Sunday, and to show I was sketching on my church bulletin this kind of flat wedge shaped fighter, which is quite a bit different looking than a lot of my other designs. And something notable about it is it's this flat wedge shaped design, but instead of having like cylindrical drives, it has this big ring shaped drive. And I've talked a little bit about how spacecraft drives work in my fictional universe. They're not like rocket engines. They are these kind of like magic devices that have like a spinning ring inside of them that acts kind of like a propeller for an ethereal layer that uh, exists in space. And they also have some other sort of fancy properties to them. And I've thought about these a design for a drive that's instead of like a cylinder is like a big ring. So I thought I'd try one of those. And I started sketching it out. On Monday, I revised the sketch a little bit and I put a lot of things in place so that we could work on it together and get to a good spot where I wouldn't be kind of dinging around with tricky stuff. So um, I'm gonna share my screen here and we're gonna get right into it. I'll get some music going here, and we will take a look at what I have so far. So, and for people who might be new, last few weeks I've been working on kind of my high detail 3D art, but I thought I'd pivot back towards game dev stuff just for this new ship. And the way I work is I kind of do these low poly designs first, and then make them high detail. So that's kind of what we're doing here. We're working on the low poly design. And I usually have this workbench file, and this new module for making the new fighter. I don't have a name for it yet, so it's just called Fighter or Unknown Fighter. And let's take a look at it here. So if I run the workbench, I'm calling a function that builds the model hierarchy. So this is it. It doesn't look like a whole lot so far because I don't have any of those extra details on it, like the thrusters, shields, sensors, things like that. So that's what we're going to be adding tonight. But we have this kind of flat, wedge-shaped design. Turn the music down just a touch, just in case it's too loud. And the radiator is extending out from the back, and the big ring-shaped drive. And something I might work on today that I don't usually do right away is some markings. So we built this capability a while back where we can add kind of a layer of flat markings for extra detail, so we can add details without having to make them actually three-dimensional. So this might be a candidate for that. We also built some tools the other week where we can do Boolean type operations with 3D models against non-manifold meshes. So that this might be a good, making new markings for this might be a good test case for that capability. So here's the size of it alongside the needle. So it's kind of shorter and stubbier, but bigger. So I'm kind of imagining this as maybe like a heavy fighter. That maybe due to the large ring design has kind of a good agility for its size. Or this could be something that I use in the future, maybe not as a fighter, but as like a shuttle. That's also kind of something that's unique about my universe, is that in-universe manned fighters don't necessarily make sense. So maybe this could be like a shuttle or something that's wasn't really intended to be a fighter that is converted. So that's kind of like the basic idea. Let me actually open it up in Blender here so we can see what it looks like there. So you can see it's a pretty basic design compared to the needle. We don't have these other parts yet, but that's what we'll be adding tonight. But yeah, and then in engine, so in engine, it looks like this. So again, very simple shape, but we're gonna spice that up with some markings and other details, and I think it's gonna look nice. I like making these simple designs first, and then kind of tweaking and adding detail. I think there's something to be said for that. So kind of alongside some other designs, it's probably the closest in shape to this owl with kind of the stub nose, and the owl is supposed to be kind of a heavy fighter, so might be most analogous to that. It's got the radiators out the back design too. Alright, so let's jump right into it. And again, for people who might be watching the first time, I'm doing this 3D modeling with Python because I like writing code. I'm a software engineer by trade, and I like writing code. And doing this kind of low poly modeling with Python also gives me a lot of flexibility. I can specify very exactly the size of things and the shape of things, and I can make tweaks to the designs without having to redo a bunch of work. And I've enjoyed building my own library for doing 3D modeling. So it uses a combination of the TriMesh library, NumPy, simple representation for meshes, and then I've implemented some different mesh processing algorithms myself. Most recently, I've been using Shapely to do a lot of things. And I'm also really excited because there's this library called Manifold that TriMesh now uses to do mesh booleans, and it's way, way, way faster. So a lot of mesh boolean type stuff is just basically free now. It's like 10 to 50 times faster than it was before. So those operations aren't things that I have to think about so much. All right, so let's get into this. And I'm gonna actually start here with my spreadsheet. I'm gonna share this. So I have this spreadsheet of my content that I'm building for my game here, and I have this sort of like low poly content checklist for each thing. So I'm gonna make a new row for this new fighter, and just to make sure that we're not forgetting anything as we're working on this. So I'm just gonna call this like unknown fighter for now. And A lot of this stuff isn't filled in. Okay, so, and the way I typically work is I do like an X for things that are done or like pretty much done, and then I use like a period for things that are started. So the YAML format is like the the um, the the game data format. So I got to start on that. As you saw, it was loaded in the game engine, and I've got a good start to the base model. So we're mainly going to be working on thrusters, shields, sensors, and comm array and the hard points. And I've got to start on the livery here, and maybe markings. Weapons I've got to start on as well. And we're not going to think about like the stats right now. We're just going to focus on the modeling because I think that's kind of the most fun and visual. I actually probably need to update some of this high detail stuff. I was working a lot on this Ashinoko ship. And I've kind of started on like the high detail devices and stuff. Actually, yeah, I got to start on the paint too. I've been busy with a lot of other different projects, so I haven't had as much time to just like sit and focus and update this kind of stuff as I should. But that's okay. You can always catch up on projects when you get the chance. It's the fun thing about just having personal projects is you're the only one who's holding yourself to a schedule. Okay. All right, so we've got the design here. I'm gonna just start cleaning some stuff up as I see it here. And I've got these basically empty part sets for the things that we need to build here. Actually, we'll just do one for markings too, so we can fill it in. And instead of doing this here, we're gonna do this here. And oh, we need to move around the hard point stuff too. So all of these functions should take kind of the base set of parts that we have right now. So parts is just my model hierarchy format. It's just a dictionary of meshes with transformations basically. And it's gonna return a new set of parts. So we'll do this for shields and sensors. Whoops. So what do we have here? We need shields. Lancers. Thrusters. Markings. This is a pretty small module right now. Usually these ships end up being about 1,000 lines when you start including the high detail stuff. We're not going to work on high detail stuff right now though. Okay, so we've got this. Let me actually just make sure that the bench script still runs, and we're going to disable the Blender stuff here. Okay, cool. And you notice that's the other fun thing about this approach is that it, for low poly stuff, it runs really fast. Now with the that manifold library, the high detail stuff, even with booleans, runs pretty fast too. But the low poly stuff basically just runs instantaneously. And that, you know, this is a nice machine. It's an M2 Max MacBook Pro, but it runs fast even on older machines. It's very basic stuff that it's doing. Okay, so how are we going to go about doing this stuff? So let's just take a look at how some of these other ships work. So typically the way I work with these, the way I add these devices and details is I define rays that point in towards the surface of the ship, and then I'll put the device wherever those rays intersect, and I can either use the surface normal to align it, or I can just stick it facing in a certain direction. So and then I parameterize things, so I can kind of, there's like a place where I can tweak things with constants. So let's start with the shields and kind of define where we want them. So I think we want a couple of shield generators on the top and bottom, and they'll just be along the middle of the ship. So we can say shield YA, something like 8, and then shield YB is like 1. So the long front and back axis of the ship is the y-axis. So that's what we'll specify. And all the units here are in meters, so it's pretty easy to reason about. What meters are and think about it. Okay, so now that we have this, we can build out a function that that puts these things on. So we're gonna stick these on the fuselage, right? So kind of following this other function, I can pull out the fuselage from my parts set, and then we're going to make a set of rays where we'll stick these. So we're going to have a ray, and a ray is defined by a point and a normal, right? So, you know, you could try to optimize this, but I'll probably just write it out manually here. So the X is always going to be 0, and then the Y is going to be shield YA, and the Z position is going to be just, it has to be up above high enough or down below low enough that we're clear. So we'll just do like 5. And this is going to be a vec3 for the point, and then for the normal here. So here we'll be facing down. So let's see. Oops. Do I have a negative? Nope, I don't have. It's funny. I forget sometimes what constants I have defined. Yeah, I guess I don't have the negative axes. That's okay. So we'll do upper, lower, upper, lower, and then second. Right. Okay. So now what we want to do is we want to find the intersections. So intersections, find intersections, simple. So when you shoot rays into a mesh, right, you can have potentially multiple intersections, but most of the time I just want the intersection that's closest to the origin of the ray. So that's what simple does, is it just pulls off the closest one. And that's just mesh and rays. And we're not going to be doing anything like averaging normals or anything, so this is going to be pretty simple. So for let's see here, intersections. So we're going to be building a part here. Actually, we need to do our shield ring first, and I think I want to follow the sizes of shield rings from the Rakan. So let me just check. There's some scale stuff going on in here. I think maybe not. One of these, there's some scale stuff. Final transform. Yeah, but I think we're doing... Yeah, all the shield rings and stuff we're doing after, so... So we can actually copy this logic, and we just need to, I'm going to just copy these constants over here. Opposite group. So we can use this as a starting point. And we will actually put the side by side with this ship in the bench, because that's kind of what is going to be the point of comparison. Okay. All right, and oh yeah, and we want to add log as an argument to all of these functions. So log just controls the level of detail, so we can kind of have the low detail, low poly versions of these ships as well as the higher detail versions. I've been thinking recently about sort of like mid poly versions that would look more like old game art, where it's like higher poly than low poly, but nowhere near the polygon count of what the final renderings I'm doing are. I might try to render some art in that sort of style, like kind of 90s CG, like what you would see in a FMV, a pre-rendered FMV from the 90s. Been kind of thinking about that style lately. Might be fun to try. Okay, so we're gonna make our part. Actually, let's just put this right in. Whoops. Let's just put this right in. Oh, Skunk's Workshop asked. Yeah, I was wondering what LOD was. I was about to ask, but you answered. Yep, it's just level. Just stands for level of detail. And to be honest, I don't know whether people pronounce it LOD or LOD. You know, kind of like some people say GUI when everybody says GUI. I'm not sure what the over/under on that is, but that's okay. I call it LOD. I don't actually use LODs in the game right now, but all the machinery to generate them is kind of set up here. That would be a good project to work on stream sometime. Maybe when I get if and when I get a vacation day. So we'll make a new part, and parent's gonna be actually so parent's gonna be shields, and actually here will be the where we have shields is parent slash, and the model is going to be our ring mesh, and then the transformation is going to be a transformation where the position actually, yeah, we'll do the position first. So the translation is going to be our point. Come on, you know what that type is. List optional array. Oh. Nice. If that actually. That's kind of silly. Sometimes PyCharm isn't the best with picking up on types. So enter dot point, and then the rotation, we're going to use this function called find panel rotation of enter dot normal, and this we have to take the transpose of 2. Oops. Yeah. Okay. So that should add a couple of shields. And we don't need extra parameters because we're just putting them right down the middle. Let's take a look now and see if this works. I'm just gonna clean up the formatting here a little bit, and just because I want to just add variable names here. Even though everything's kind of self-explanatory here, and I think this is all designed so those bevels aren't applied if the LOD is yeah, the bevels are only applied if the LOD is greater than 0. So I have this kind of shared library of component stuff, and eventually here I'm going to extend this so that we have even more different styles of things, and the higher detail stuff is even higher detail. Okay, so now res key this part. Alright, let's take a look. Nope. Just need to add the LOD arc here. It's kind of funny. I could have sworn that the problems functionality in PyCharm used to aggregate stuff like that, but yeah, oh well. Okay, and let me just, yeah, I always have LOD as the second argument. So here we go. Yeah, okay. So we've got, I see 2 of them. I wonder what happened to the others. Okay, let's actually, we can just bring this up in Blender and see where that stuff ended up. It's probable I just gave it a nonsensical thing, and it's let's see, because this is the one that's at y = 1. Yeah, so it's not actually long enough. 1, 2, 3, 4, 5, 6. Yeah. So what do I want? I want, instead of 1, I want maybe like 0.5 and, or 0 actually. Yeah, 0 and 1, 2, 3, 4. Yeah, we'll do like 0 and 4. Yeah, we'll do 0 and 4. Yeah, nice. Something else that I did recently, which I'm going to talk about in a separate stream, is I changed the way Polyscope works. So I've been using this library called Polyscope to do rendering, and actually I actually set this up on a live stream. But it had this. So Polyscope uses matcaps for rendering instead of like normal kind of lighting calculations. But the goofy thing about it is that it only uses the surface normal for the matcap, whereas usually you use both the surface normal and the eye vector, so you can do a reflection. And it wasn't doing that, so I actually updated the shaders so it does. So you get a little bit nicer shading on things now, and it's easier to pick out, maybe a little bit easier to pick out some of this stuff that happens on flat surfaces. But Blender's still the best for that. See, what you want to see is you want the design to be striking even when it's low poly, and I think this is, you know, this is like, I'm starting to see what I was picturing in my head in here. And actually, let's add a couple of shield rings on the rear end too, as long as we're doing that. So those are going to be facing forward at like what, minus 1, 2, 3, 4, 5. Yeah, I think we can do -5. And centers at 1. I like when things have nice even numbers. Makes me happy. Okay. So we just need to add a couple more arrays here. And we'll give these shield ZC, because they're always going to be stuck on the rear, but we want to specify the Z offset. -5, -5, shield ZC minus shield ZC, and then these are going to be both Y-hats. All right, let's see if that works. Nope, not quite. Let's see, are they there? Oh, they are. I just need to stick them on the reactor, not the fuselage. So these I need to. So we'll just add a little. We'll just repeat this because this is pretty straightforward. Sometimes it's best not to get too clever and just repeat code. And I'm being lazy tonight. I'm using the mouse a lot. I'm trying to. I'd like to get to the point where I don't use the mouse as much, but sometimes I just don't really care. And, so we're gonna zip intersections with range of 0, 1, 2, 3, 4 to 6, and shields. Oh, shucks. Actually, this is not what I'm going to do, because shields is going to be parented to fuselage. So I actually just want to leave this and just tweak these like this. So it's going to be inner dot point plus, or yeah, minus mu dot v z, not vz, vy of reactor thick divided by 2. Yeah, there they are. Okay, that works. Okay, and I'm thinking now about where I want the next set of components. So I'm thinking we want to add, whoops. What happened to... Oh, I only want to do this if... There we go. Okay, cool. Okay, so where do I want the next set of parts? So we want to do thrusters, and what I'm kind of picturing is a set of this is kind of an interesting problem. I like to think about what makes sense for these things. So there's not really any room for vertically oriented thrusters on the back, but I could do both new and old style ones. Let's see here. The old style thrusters might make more sense, but I was hoping to keep the sides clear for weapons. So I guess what I was originally thinking was to have like 4 thrusters on the front, but then we'd want corresponding ones on the rear. Maybe I extend this rear part a little bit to give a surface. To put thrusters on in the rear, huh? Does that make sense? Well, I can always do top-mounted weapons. Yeah, you know what? That might actually make more sense to have the older style thrusters on the sides. Let me think about this. Yeah, because it would be more. It's more important for the thrusters to kind of have that space on the side than weapons. Yeah, and then that's what I want, because then I want the antennas to go on the top. So Skunk's Workshop is asking how big they would be. So the thrusters, like these are the new style thrusters. The old style ones are about the same size. They're just like little blocks that kind of stick out from the side. So yeah, we have these kind of sloped shoulders, so it wouldn't necessarily make sense to have those thrusters sticking out. They make more sense like on the surface here because this is more flat. Okay, yeah, let's try that. So this is going to look a lot like whoops. A lot like our shield setup here. Oops. Jeez. I can type, I swear. I'll just actually copy this. Oh shucks, and I closed it. So we'll just guess at where things are gonna sit. If so stir A Y is gonna be at like 5. Thruster BY is going to be at like -2 or -1, and well, yeah, the X doesn't matter because they're going to be stuck on the sides. Okay. And we're gonna skip this logic here, and we're gonna actually just and we typically go left, right, so left is going to be right, and Z is going to be 0 here, and X hat, and we'll repeat this for B. It's kind of fun when you start sketching these things out, how they turn out a little different than you had pictured in your head. And so here, instead of using the intersection normal, we're going to use the negative of the ray normal. Actually, you know, normal's probably not the right name for the... It's more like a direction normal rather than like a surface normal. We're going to use the negative of that because they're just going to be coming straight out. And when we might actually need, might have been a little hasty in getting rid of that extra translation. Extra equals 0. We'll add this back in. It's just a placeholder. Okay, so now let's take a look at the thruster model that we're going to use. This style, RCSA. And we'll once again copy these sizes from here as a starting point. And ring subs is going to be 3. Okay. Whoops. I don't know why it comes up with rules sometimes for move to top. It's annoying. Just clean up these comments here quick. Okay. Some people like to use automatic formatters. I kind of like formatting myself because it's fun. It kind of gives me time to think about the code that I've just written. Think about if there's a better way to do things. Wasn't destructuring that correctly. Okay, here we go. Okay, so first thing I'm seeing right off the bat, I've got a Z offset that is not correct. So let's not spend too long looking at that before we fix it. That's interesting. What is going on there? Oh, am I... Oh, yeah, that's what happened. That's supposed to be 0. Okay. Yeah, okay, so we need to add a little extra out. But is this what I want? Yeah, because this would give us vertical... it would give us rotation, it would give us... Yeah, and that's close to efficient. And that shouldn't be 0. I thought Yeah, that needs to be farther back, so that needs to be not 0, but or not -1, but 2.5. Okay, and then the extra is also going to be opposite the ray, so it's going to be minus ray dot normal times let's see here. That might be too much. We'll just see. Oh no, that looks just about... Hey, look at that, just about right. Let me take a look at this once. So actually we could come out a little bit farther even, couldn't we? Yeah, we can do 15 centimeters. I need to go through and make a list of the best of these White Bat songs that I listen to, because some of them really slap and other ones don't. Okay, this looks very, very close to what I want, although I might nudge that one forward a little bit. Okay. Too much. Perfect. See, when you start adding these smaller details, you can get away with a simpler fuselage. Like, it's tempting to look at that fuselage and say, oh, I've got to add a whole bunch more detail and stuff to it, but I don't think you do when you start adding this detail, especially once we get like the antennas and stuff in there. It's gonna look really nice. And sensors. Okay, so yeah, sensors I think are probably the next thing. Oh, Skunks Workshop says, lol, your work is the main focus anyway. Yeah, and that was really cool to watch that happen in real time. What the adding the components. Yeah, it's fun. I feel like it's taken me a couple of years, but this stuff is kind of to the point now where I can make what feels like a lot of progress for me in one sitting, and it's fun. It's fun to be at that point. Oh, so we got to add sensors, comm array, and hard points. And I think we've gone a little bit over an hour at this point, but I'm going to keep going because I would like to get this done, and I think it's going to look really cool once it is done. So we're going to keep going. Okay, so yeah, maybe we won't get to markings today, but I think we can get to everything else. We've kind of got a pattern here now. Okay, so sensors now. So sensors is going to follow more after shields. So I've got a couple different sensor designs that I use, and we'll just grab these here right away. And again, we'll grab these parameters. So yeah, I just have some logic. Yeah, and see, I think I came up with a better pattern of doing this because I was just sort of enumerating out what direction things should face here when we can just use the ray direction. So yeah, actually this is going to be more like this, like we did with the and then we kind of choose which model we use, and I don't think is this. Oh yeah, that's something I need to fix. There's like 2 different sensor models and they have different orientations. So that kind of befuddles things. So we're just gonna make a to-do for that here. So I don't think I need to do that actually. I can just say what is this and add an exception. And what do we do? Probably a couple on the top, a couple facing forward. It's kind of how I've been doing things. Maybe one facing in the rear. Okay, so Edward Ferrari says, hi, are you using Vim bindings? No, I'm not using Vim bindings. I'm just using the default PyCharm bindings. So I never learned Vim. Kind of a funny story. I actually used Emacs a little bit in college, so that's kind of the way I would lean. But I grew up with DOS and stuff like that, so I never really learned modal editing. So I just used the sort of default PyCharm stuff. I'm using the mouse a lot too. When I want to, I can not use the mouse. I'm not really worrying about it too much now, but PyCharm actually has a lot of really good shortcuts and keys. You can do a lot without using the mouse if you want to. Edward, are you a Vim user? You like Vim? One of my good friends is really good with Vim and likes it a lot. I think we were working on a project together where we had to use VS Code, and he found like a Vim bindings stuff, Vim bindings configuration for VS Code that he liked to use. Yeah. Yeah, so one of the cool things about PyCharm is that it yeah, nice. Yeah, that's I've thought about it. Trying to learn that, but I never have the motivation. One of the things that I really like about PyCharm is that, and I think VS Code does this too, is it provides some really nice ways to search. So like you can search by hitting double shift, and then you can like search actions by hitting Control Shift A. And when you search for an action, like say I want to I could even if I didn't know, say, how to select the whole line, I could just start searching select yeah, if I just start typing select to end of line, I get move caret to end of line with selection, and or like move caret to code block, and you could just use that, right? But then it also tells you what it is. So if you weren't sure, you know, like one I use a lot is like move caret to next word, you know, like where you're like using basically command or control to like move. So like, but if I didn't know that, I could just start typing next word and then it would come. So it's like PyCharm is really easy to search and find these things. Okay, so we're gonna take the DOM mesh if index is less than 4, else the DOM mesh long. And let's see here. I'm actually gonna do this as well here. If or else, and then for the front-facing centers, front-facing ones, we just want them facing forward. So I think we just want I3. Nice. Yeah. I think so. So Edward says that's pretty cool. I honestly didn't know that you could have such keyboard motions in a default editor. Good to show how feature-packed the IDEs really are. Yeah, that's a really good point. I think a lot of guys, especially if they're kind of newer to programming, they kind of want to be like a Vim wizard or whatever, and they think I have to use Vim to be able to do that. But you know, pretty much any IDE has lots of nice keyboard shortcuts that you can use. So like I'm not personally a huge fan of VS Code. One thing I really like about PyCharm is that it's built on Java, so it's a little bit more performant than like the whole Atom JavaScript thing or whatever that VS Code is based on. But like they're all very customizable. So like you can use Vim key bindings in VS Code. There's actually a package that I use that puts the PyCharm key bindings in VS Code, so you can do that as well. And then there's always a couple little things that you have to tweak, but once you get good at it, you can kind of use whatever. So yeah, you know, learning Vim stuff is kind of always been on the back burner for me, but you know, I think you can find and be efficient in whatever IDE you'd like. So Edward, are you doing Python programming or something else with the VS Code? Okay, Python programming, nice. Yeah, so it's cool you're getting into machine learning. So I kind of got into Python through machine learning and like computer vision stuff, and that's mainly what I use it for in my work. Awesome. So it's really cool that you found my channel in your recommendations. I'm hoping someday to do some machine learning stuff on here. So I've worked in machine learning for like 10 years or so, and in my current position, my current job, I actually don't do so much machine learning. I'm more working on like 3D computer vision type stuff. So I need to I've been wanting to stay up to date with some machine learning stuff. So that might be I thought it might be a good excuse to do it on the channel, because I think there's you know, it's a topic that a lot of people are interested in. I'm actually sometimes I'm not so interested in it. That's machine learning, something I'd rather do in my day job and do something else when I'm not working, but like this, something more artistic. But there's some technology specifically, because I'm working more with 3D computer vision now, that I'm probably not going to get a chance to do in my day job for a while. So in my last job, I worked for about a year on NLP, LLM type stuff, and I'd like to get some of that stuff back out again to see where it's at, because I haven't done much with it since maybe about yeah, like about April or May. And I keep seeing some really cool stuff on Twitter that I wanna try out. So that might be a potential topic for sure. Okay, so I need to make some constants for the rest of these sensor positions here. So let's see, what do I have here? So sensor AY is going to be like 4. Okay, so Robert says, yeah, if you had a chance to go for it. If you did for 10 years a while ago, it will seem like a dream come true nowadays. Can create simple models using PyTorch and whatnot, very basic. You know, that to me is kind of the most fun thing. So I was kind of lucky to be able to do some work in my job with deep learning when it was first becoming really popular. And that was kind of my favorite time. I feel like nowadays the models are all really, really complicated, and they're kind of they're kind of not so much fun anymore. Like everything is just transformers. I started doing some research into like the current state-of-the-art computer vision stuff, computer vision models, and the models are just so complicated. The losses are just so complicated. It's kind of not so much fun anymore. It was a lot more fun when you could kind of implement the state-of-the-art deep learning stuff yourself. I got a kick out of doing that, and I was fortunate to be able to do that for a while. So let's see here. This should be more like 8, and we'll call this, actually this will be 0, but we want sensor sensor X, sensor BX. Yeah, one of my proudest moments was we actually implemented graph convolution ourselves using like the sparse matrix stuff in PyTorch. And I mean, it didn't really work for what we were using it for, but it was really cool to go through that process. Nowadays it's just like download everything from Hugging Face. It's not so much fun. Yeah, well, it's fun. I'm just starting to build my channel, Edward, and you know, there seems to be a good reaction recently. Like YouTube seems to be kind of like taking my stuff and recommending it, and it's fun to talk to people. I do a lot of work by myself at my job, so it's kind of fun to like talk to people about programming, geek out a little bit. Yeah, I think Edward says that answering questions is a more powerful tool than some streamers think. I hope so. And I like teaching too. You know, a lot of the work that I did at my old job was like teaching and like helping people out with things. And I still think that's fun. I mean, one reason why I do this is because like I have this kind of goofy style of programming Python. It's more functional. Don't use like objects too much. And I think it's really powerful, and I feel like not enough people do it, so I just want to like show some examples of what that style of coding looks like, kind of give people some alternatives to think about, and how they go about their their work. Still trying to find exactly what my niche or niche, or however you want to say it, what that's going to be, but it's fun to think about. Okay, let's see if these sensors worked. I'm sure I did something wrong in here. Yeah, there we go. So sensors. Okay, yeah, that's almost right. They seem big, and the orientations are wrong, but not far off. Red, green. Oh, these are all y-axis facing. Let's just make things easy on ourselves, and oh, there we go. That's the problem. That's gonna fix some of this. Yeah. Edward says he's a newbie with Vim. Yeah, I mean it takes a long time, for sure, but I think doing a little bit at a time, you know, you'll see that progress over a period of years, and it's fun. Yeah, thanks for hanging out, Edward. It's good to meet you, and I hope I'll see you back in another stream. And if you like what you see, I've got a lot of other streams about some really interesting topics, mostly 3D stuff. I've got some general Python stuff as well, some game dev stuff, some Blender stuff too, so check out my other streams if you're interested. And I'm trying to live stream like once or twice a week, so hope I'll see you around. Okay. Okay. So is my logic just completely off? Here on this stuff, so I'm doing identity is greater than oh. Yeah. So I think we're gonna kind of cheat, and we're just actually gonna transform this guy. And we're gonna twist it from facing forward to facing up, so it's going to be rotation X 90. Oh, wrong way. Still looks big. What is going on with that? Oh, maybe not. Yeah. Okay. Actually, let's use just gotta do a couple things here. We gotta add a prop for auto smooth angle. here. And then I do actually want to use this. I'm going to bring out this logic too. So if index is less than 2, row equals this. It's less than 4. Row is going to be I. 3. NT dot mu dot rotation Z 180. So I'm gonna add a sensor sticking out the back. So this is just gonna be 0. It's 8. Let's just be stuck right in the middle. And oh, flipped upside down there. What? I'm confused now. Oh, Edward can hang out a little bit more. Yes, so Edward is asking, so I'm using macOS for development, but what do I think about Linux? So Linux is my preferred environment. I use macOS because it's for my streams, because it's just a little bit more convenient. There's a nice webcam built into the Mac that I don't have to get out. But this whole project that I'm building, like with the game dev and the 3D art and stuff, it works on both macOS and Linux. And I use PyCharm, same version of Python, same everything, and it just works on both. I personally prefer the Linux desktop UI. I use Ubuntu, and I prefer the Linux desktop UI to macOS. I find it a little bit more. I'm not a lifelong macOS user. It's something I've just started in the past couple of years. So there's just lots of weird quirks to macOS that I struggle with sometimes. But yeah, they both work fine, and I don't lose too much sleep over which one is better. Do you use, so you say you use macOS as well. Have you used macOS for a long time, or is it something that that you're kind of new to? I grew up with DOS and Windows and stuff, so that was kind of my preference up until a few years ago. Then I switched over to Linux for most of my projects. I still use Windows for games, and then recently for work I've used macOS for my work, and I like that, like my day job. That's kind of how I got into it. Okay, yeah. So he has, like, Edward says he has a MacBook Air M1 that he got for learning. Nice. Yeah, so I have but you're looking at System 76. I have a friend who has a System 76 laptop, and he likes it a lot. I think it's hard to say whether I would. So this computer that I'm using now is actually from my last job. It's like a very small company, so the IT department was basically, we're gonna buy you a computer and then you can just keep it. It's a really good computer. I like Linux though. I would be tempted to try System 76 for my next one, but I don't know, man. The MacBook Pro is just such a good computer. It's really hard to argue with. It was like an immediate quality of life upgrade from the cheap. I have this like older Dell laptop that I have Linux on that I use, and it works fine. It's just not as good hardware. I would be curious to try an Air as well, but the Pro is just so nice. Like, I don't find it to be too big or heavy, and the fan almost never runs unless you're doing something really intense. So it's like, I don't know. It's like basically it's a very powerful machine that basically has all the benefits of something smaller, except it's a little bit bigger and heavier, and I like a bigger screen. So, and I really like the idea of the ARM processors. I think it's cool to be able to run the same code across different architectures and just have it work. It just makes me happy. I hope we start seeing like some non-Mac ARM stuff and good Linux support for it in the future. I'm looking forward to that. I think the software is probably there, but I don't know about the hardware. Okay, so we're gonna do the same kind of logic here. So we're gonna do mesh okay. Nice. So Skunk Workshop has a Mac Pro. Yeah. You know, and is that a, I'm assuming you mean like the desktop computer, or do you mean a MacBook Pro? I think those Mac Pros are pretty cool too. And I use my computer as a desktop like 90% of the time, so something like that would work. Nice. Yeah. It's fun having a MacBook Pro laptop, but the problem with it is the thing is like it's expensive enough that I don't want to just like haul it. Like I don't want to like haul it to Taco Bell to work on my project. Because it's worth so much. So it really mostly stays inside the house. Okay, this is looking good. I'm going to... We'll get the comm array in here, and then we'll see about hardpoints. So... I'm going to steal stuff from this as well. It's going to be like something like -1 here maybe. Yeah, those desktop machines are really cool. What would be really cool actually is like a Mac Pro with a really powerful NVIDIA GPU in it. That would be sick. And something that had like the nice Apple Silicon GPU as well, so you could kind of switch. That would be cool. Let's see how I did the antennas here. Okay, yeah, we don't want to do this. We want to do the same kind of thing that we did before, where we do the decals. I'm starting to wear out a little bit, so I'm gonna try to bang this out. So let's just define ant x as like, let's see here, 3.5 or something. And we'll do this. Yeah, this'll pop right out here. Yeah, okay. So yeah, some discussion about GPUs. Okay, so Edward has the last question before he has to go. Have you tried the Godot game engine? Have been lately using it for simple projects to get synthetic data and select. Yeah, so I've heard really good things about Godot. Oh, nice. Yeah, thanks for hanging out, Skunk's Workshop. I appreciate it, and I hope that you're making some headway on your projects too. Nice. Yeah, so about Godot, I've also heard really good things about it. The thing I don't like about Godot is that it has its own programming language. I would really like to use, like if I'm going to be writing code, I'd like to be writing code in like a more general purpose programming language. So for my project, I'm using the Panda 3D engine, which is, there's a lot of problems with it, but it's Python. So it's all Python code. I'll have to look at Godot again though, because like if you can you write C or C++ with Godot? I've been, like in my current job, I've been getting back into C++, so that might be something that I would look into. But yeah, that's kind of the main reason that I haven't looked at Godot is too much as it's got its own programming language, and I'd rather write in something more general purpose. Yeah, Edward says, yeah, totally. Okay, C# support, yeah. Interesting, yeah, I might check that out. I wrote some C# a long time ago, and I'm familiar with Java, so C# wouldn't be too alien. I kind of like those languages actually. Okay, so get rid of this spin code. Almost done here. Yeah, cool. Yeah, well, I'm happy that you enjoyed watching. It's kind of fun to watch people when they know what they're doing. And I'm still learning, of course, but yeah, hope to see you again. And same to you, Skunk's Workshop. Thanks for hanging out as well. Probably won't be going too much longer here, but it was really fun talking to both you guys tonight. Okay, so I have to finish these antennas. And you know, I might just knock the hard points out too. I feel like we're making good headway. And the hard point code is going to look really similar to the antenna stuff as well. So just copy this guy. Do I have these sensors? Let's see, COM array. Okay, so just been using ant as a prefix, and the right spot here. Yeah, COM array. this might not be the right direction, but we should be able to figure it out here. And we don't need this. Okay, so these are not anywhere near the right direction, but okay, and this guy's wrong too. Let's see, red, green, blue, yeah. Okay, so let's fix the sensor first. Dome mesh. It's gonna be this guy. And okay, yeah, so that's kind of the trick with the antennas, is like what yeah, okay, so that's good. I kind of typically want stuff aligned like this. So now the question is, how do I get them pointing the direction I want, and why is I only have one on that side? 5, 5, okay. That, oh. There we go. Okay, so these are pointed the right direction, so we want to basically add an additional rotation here. And that's what I was doing here, is I'm adding this additional rotation. So we want to just basically pull this out. So our base rotation is going to be this guy, right? And then on top of that, we want to add in this X angle here. We're using the left multiply convention here. I didn't actually use it. Okay, there we go. Yeah, okay. So actually what I want to do here is we're going to actually switch these around. So we're going to do this one first, and then we're going to add this one in. And if this doesn't work, then we're going to cry and go home. Okay, that is almost exactly right. I just want to shove these outward a little bit and push them back farther. Yeah, cool. Okay. almost exactly right. And that I can tweak like this. With minus 1.5. And, where's my... X? There we go. Okay, so 3.75. And they're stuck in there kind of far, so we're gonna shove these out a bit. So like here you can see we're offsetting them by some fraction of the length. So it'll be like, maybe we'll do another rotate. But this is a cool one. Okay. And mu.vy. So we're offsetting it by the direction it's ending up pointing, right? So it sticks out farther. Whoops. Oh. Yeah, there we go. And I'm gonna just increase that. I want these back a little bit farther, and I'm gonna increase that X angle. Let's see, X. Can I go as far back as 2? And we're gonna do that is more like it's almost exactly what I want. Okay, we're really close. Just gonna do the hard points and then we're gonna be done. And the hard points are gonna be really easy because it's basically going to be the same as the shields. So let's get into it. Not the shields, the antennas. And we'll save markings for another time, but I'm pretty happy with the progress here. So we're gonna want these weapons kind of on the front surface, and we'll have 4 hard points. Is gonna be something like, also something like 3, and intersections. Hardpoint mesh is going to be this. We'll copy these guys again, and we'll just toss this all in here for now. And do the intersections again. Point, index. We don't need this guy anymore. It's just going to be this. Model is hardpoint mesh. And what am I using? Okay, yeah, height. I think this is all good as is. And we just gotta do hard points. No, not even. These are parented directly to the fuselage. So just do that. Okay, I think maybe my X values are too far off here. I'll just bring this in. Where are they? Oh. These. Oh, I'm not even calling it. That'll do it. So the idea with hardpoints, right, is there are places where I can attach a weapon, and I have little models like of the surface, so there's some detail there that's added. And then I also have data that lets me attach weapons to that specific part in the in-game model. Okay, yeah, we don't need that anymore. Okay, there we go. This is more like what I was expecting to see, but we don't want them there, we want them back there. So where are they gonna go? It's gonna be like also maybe at 0 for Y, and yeah, let's see here. 0 for Y and dash I try 3. Yeah, look at that. Maybe a little bit farther forward. And I think they probably don't need to be this high, so we can cut that down a little bit. Yeah, okay, now we're cooking. But now we need to bring him in a little bit. And that's too much inset as well. So, oh yeah, wrong way. This should be 1, and that should stay 3. My X and Y backwards. There we go. Okay, and that shouldn't be 1, it should be 0.5. Okay. Now I should be exporting the hardpoint locations correctly as well. So let's see if this actually works. So we've got our model done. Now we can update the game data to look at it in the in engine. So I'm going to just double check my hardpoint data. Yep, doing 4. Let's see. Data. Yeah, so we want to use hardpoint height here. Okay, and then in here we can do 4 weapons. Now the offsets might be a little goofy here. Let's see if we have whoops, wrong weapons file. Where is it? So there's a system that I built for kind of like fitting the models together correctly on the hard points. I'm just double checking that I have everything correct for that, because this other ship sort of would offset things to the side, and that's probably not how I want to offset things here. I want to do like a vertical offset. So let's see if I can find that. Spacecraft. Weapon models. Bins. Yep. Okay, now the data is going to be here. So offset left, offset right. So for mounting on the bottom of this ship, we might have to add a new. Let's see. Translation is. Yeah, you know, we might have to save the actual weapons mounting on the hard points for another day, because I suspect. Actually, let's just try to guess at this. Let's just try to guess at this and see if it set top. So instead of minus max, it should be plus min, right? Okay. And this will get regenerated when I run the export script. And let's see here. So our hard points, I think I had the top ones first and then the bottom. subs in here. Yep, top and then bottom. So we're gonna do offset. Oh yeah, I remember how this works. So left, right. So these are just gonna be both offset top and then offset bottom. See if this actually works. Let me just add this into the size comparison. Doesn't like something here. And it doesn't like error list index out of range. Weapon models. 0, 1, 2, 3. Let's just try. Yeah. So there's some issue there with the hardpoint indices, but there it is in the lineup. Yeah, and these aren't really working. I need to build something to support hard points that actually have an angle to them. But that's okay. Everything else is kind of working. And yeah, I don't know what's up with this. It's like it thinks we don't have 4 weapons or 4 hard points, but we definitely do, right? Because when we grab the hardpoint data, there's 4 of them. That's odd. Okay, well, anyway, for now, this will just be like a civilian, not really a fighter without weapons, but that's okay. So we'll just comment that out. And then we'll update the livery and take a look at it in the game engine, and then we'll be done. This took a little longer than I thought, but had some fun conversations, and it was a good time. So yeah, there it is. Not as complicated as some of the other designs, but that's okay. I like to have a range of designs that kind of look like they were made by different manufacturers, and I think this one definitely fits into that. This might be really best as sort of like a civilian shuttle type ship. So, all right. Dast, we just load it up in the engine and see what it looks like. There it is. Okay, just seeing a couple things. I'm gonna up the the auto smooth on those sensors, and then we'll be done. Oh yeah, 45. So we're gonna do something like this. Okay. Whoops. Nice. Well, I think I got to a good stopping point. We got pretty much all of the devices and details on there, with the exception of markings, which is kind of a new capability, even for me. So I think it's at a good spot. I'm gonna take a screenshot quick for Twitter, screenshot or two, and look at one of it. Zooming in, so it's a little bit. Bit closer. Nice. All right, well, thanks everyone for hanging out. I think we made some good headway. Can actually, back in my tracking spreadsheet here, I can definitely mark off all of these as at least started, and really most of these are basically done. So some great headway, and it's fun hanging out. If you're interested in this project, I have a lot of other streams you can go back and watch, and some videos as well that kind of show some clips and stuff from the game running. I talk a lot more about, you know, the project and what the goals are. Also have some general videos about Python programming and 3D stuff, if you're interested in checking it out. So, but thanks again for hanging out, and have a good evening, everybody.